Hi, welcome back to Math 520 and welcome to week 10 of the semester. This week we're going to continue with section 6b of Axler, and we're going to wrap up then chapter 6 by looking at section 6c. Now there's several important ideas contained in these sections, and these ideas are going to be really building on the ideas that we saw from the inner product last week. So I would say that there are two fundamental definitions that we have this week. The first one of which is what it means for a collection of vectors to be orthonormal. And the second important definition we're going to have is the definition of a dual space. So we say that a collection of vectors is orthonormal if I take any two of the vectors in the list and their inner product is going to be 0 if the vectors are different from each other, which means that they're pairwise orthogonal. And the second condition that we have is that the norm of each element of our collection is 1. So this means that it's going to behave something like the standard basis. They are going to form the edges of a cube in whatever your vector space is. Right, so everything has length 1, and any two vectors in the collection are going to be at right angles to each other. That's the idea behind an orthonormal collection of vectors. And then the second thing we're going to talk about is something, second definition we're going to give is something a little bit more abstract, which is the idea of a dual space. So if I have my vector space V, then I can look at all the linear maps from my vector space to whatever the field is. And so if I have a real vector space, I look at linear maps to R. And if I have a complex vector space, I look at the linear maps to C. That's the dual space. It seems very innocuous, but it is actually an important and very useful recurring idea that's going to show up over and over again in looking at vector spaces. Okay, so we have those main definitions that we're going to have in this chapter, or in the rest of this chapter. The second thing we're going to have is we're going to have a collection of very important theorems. And I would say that these are three basic ideas that we have. The first one is the Gram-Schmidt orthogonalization algorithm. And what this does is it takes as input a collection of vectors, let's say a basis, or you can take a linearly independent list of vectors, but let's stick with the basis. You take a basis as your input, and it spits out for you an orthonormal basis. So that's the idea of this Gram-Schmidt procedure, and we'll talk a little bit more about that on Tuesday. The second thing that we're going to have that's a deep and important theorem is the Riesz Representation Theorem. And this is a description of the dual space. It's saying that the dual space of a vector space can be understood by means of this inner product that we're talking about. And the last thing we have is a very geometric fact, which is about orthogonal projection. And the key idea that we're going to look at is that, or the key geometric idea that you know already, is that if I have a line and I have a point not on the line, the distance between the line and the point is given by dropping the perpendicular. And more generally, if I have a plane, so let's imagine that this notebook here is a plane, and I have some point, then the distance from the plane to the point is given by looking at the perpendicular, right? If I drop a perpendicular to my plane, that is the distance from the point to the plane. And what that means is that's the minimum distance of all the possible distances between this point and a point on the plane. Okay, some reminders. As always, homework is due, except this week, the homework, I'm pushing it to Thursday as an experiment to see how that goes for everyone. I haven't been getting to grading it before Thursday anyway, and this way you can meet on Thursday morning and we can talk about it if there's anything that's unclear. So hopefully you find that helpful. Give me some feedback if you like it, if you don't like it, and we'll see how that goes. So again, homework due on Thursday instead of Wednesday. The other thing is your discussion posts. Those are still due. The first one is due on Wednesday, and then your 1 or 2 follow-ups are due this coming Sunday. All right, so the Piazza part is unchanged. And I hope to see many of you on Tuesday in our Zoom meeting. And also, I hope to see many of you on Thursday morning.